Hello people, so today we'll be solving LeetCode daily question, that is 20445 second minimum time to reach destination. And in this, a city is represented as a bidirectional connected graph with n vertices. Each vertex is labeled from 1 to n inclusive, and the edges in the graph are represented as a 2D integer array edges where each edges of I is equal to ui vi denotes a bidirectional edge between vertex ui and vi. And each every vertex pair is connected by at most one edge, and no vertex has an edge to itself, and the time taken to traverse any edge is time minutes. And each vertex is having a traffic signal which changes its color from green to red and vice versa every change minutes, and all signals change at the same time. And we can enter a vertex at any time, but we can leave the vertex only when the signal is green, and we cannot wait at a vertex if the signal is green. Okay. And the second minimum value is defined as the smallest value strictly larger than the minimum value. For example, the second minimum value from 2 3 4 is 3, but the second minimum value from 2 to 4 is 4. And we'll be given n edges time and change, and we have to return the second minimum time it will take to go from vertex 1 to vertex n. And note is that we can go through any vertex any number of times including one n. And we can assume that when this journey starts all the signals have just turned green. Okay, so for example, if this is our graph, so the path to reach from 1 to n, that is 1 to 5, we are having basically two paths. You can see that are 1 4 and 5. Other one is 1 to 3, then 3 to 4, and then 4 to 5, because we cannot we have to start from 1 and reach to 5. Like we have to start from 1 and reach to n node, so there is no path from 2. If we go to 2 first, then we can go to 5. Okay, so the two paths which we can take are I've already told you that one path is 1 to 4 and then 4 to 5. But in this, the time taken will be, let's say, 3 minutes only. 6 minutes, because from 1 to 4 it will take 3, then 4 to 5 it will take another 3, so that sums up to 6. But if we'll follow this one path, that is 1 to 3, so here we'll have to spend our signal will not change, so 3 minutes, and then we'll take another 3 minutes, so we'll enter the 4. Okay, yeah, so now by the time lapse is 6, and we have to wait at 4 for 4 minutes, because the time elapsed, so that the time will make up to 10, because if let's say we are here at 6, at the fifth minute all the signal changes, so it's given on the question only that we can enter any vertex at any point irrespective of the signal, but we can leave it only when it's green. So it will be green on like every multiple of 5. So the next multiple of 5 that is will come is 10. Okay, so we'll have to wait for 10, and then at 10 minutes, for basically 4 more minutes at 4, then we'll go to the fifth vertex with 3 minutes. So overall the second minimum time maximum time is 13. Okay, second minimum time, sorry, yeah, second minimum time is 13. So for this we'll be using BFS traversal as well. BFS traversal. Firstly, let's create the graph. So it will be a map of integer comma list of integer. Okay, let's call it graph, that is equal to new hash map. Okay, and then we'll be traversing in the edge. Let's first create the graph as well. For int edge in edges, what we'll be doing is we'll be doing a graph dot compute if absent with edge 0 comma k, that's a new array list dot add edge 1, and we'll change this values. Here it should be at 0, and then here it should be edge 1. Yeah. Okay, now let's have two distance arrays. Basically, let's int dist 1, that is equal to new int of size n plus 1 to make it one based indexing, because the vertex are given from 1 to n and not from 0 to n. Similarly, we'll be having a distance 2 graph as well. Dist2 basically calculating the first minimum distance and the second minimum distance for the two nodes for reaching from that particular node. Okay, and then we'll be initializing all the indices of this by -1 for int I equal to 0, I less than n, less than or equal to n, I plus plus. And let's just to make it a bit clear, I'll do it from 1 to n. Okay, Now we'll be making it that dist1, oh sorry, dist1 of I is equal to -1. Similarly, distance 2 of I is equal to -1. -1 basically means that we haven't visited that particular node still. Now for BFS we need a queue, so let's have a queue of integer array. Let's call it BFS, that is equal to a new linked list. Okay, now while, oh sorry, let's just update the BFS first. So BFS dot add a new integer array of 1 comma 1 uh, 1 comma 1. Okay, and let's just update the at the dist1 first should be 0 because it will take us 0 minutes to reach at the starting vertex. Okay, now while not BFS dot is empty, let's add some spaces, man. Yeah, while not BFS no, while not BFS dot is empty. Okay, we'll be having the current node that is, and its distance as well, so that will be equal to oh sorry, let's just do a BFS dot poll. Okay, and now let's we are having the node that is equal to current's 0th element and distance that is equal to current's first element. Okay, now let's have the time taken as a variable to reach that particular node. That will be equal to if my, oh okay, did I miss something? Oh okay, so we are basically checking the frequency, my bad. It's not the distance, it's so the frequency. Yeah, that's why it's here 1 1 as well, because I forgot to mention it here that it's 1 1 because we have visited first node first time, so basically it's the frequency counter, let's say. So we'll be updating that if frequency is equal to 1 sorry 1, that means we are visiting it for the first time, so we'll be using distance 1, oh sorry, distance 1 uh, of node. Otherwise we'll be using distance 2 of the node. Okay, now we'll be checking that if time taken mod uh, changed, oh no, oh sorry, my bad, it should be instead time taken by changed mod 2 if it is equal to 1. So what we'll need to do is we'll have to wait of that particular vertex, so we'll be updating by time taken as time taken will be equal to change, oh sorry, it's change into time taken by change plus 1 and plus the time. Else if this is not the case, okay, yeah, it's the time variable is the current time which we need, and otherwise we just need to add the time taken to reach that particular vertex into the time taken plus equal to sorry, plus equal to time. Okay, and now we'll be checking that if not graph dot contains key, my particular node, well basically let's say we are checking this for two case, so we cannot go any further from this particular node, so we'll be doing a simple continue for that node because we cannot consider that. Otherwise we'll be doing that for int, I'm calling it na instead of neighbor hole, so we'll be doing a graph dot get the current nodes neighbors. Okay, then we'll be checking that if distance first of na is equal to -1, that means we are visiting it for the very first time. We'll be doing a distance 1 of na will be equal to my time taken to reach that particular node, sorry, and we'll be also adding it to the queue. So bfs dot add new integer array of the current neighbor along with its frequency, that is 1. Else we'll be checking that if distance of 2 distance 2 of neighbor is equal to -1, and distance 1 of neighbor is not equal to the time taken. That means we now need to update this. Okay, and firstly we'll be saying that if my neighbor is the last node only, I'll just return the time taken. Otherwise, what I need to do is I'll be updating my distance 2 of neighbor as time taken to reach the current vertex. Along with, I'll be adding it to the queue. So bfs dot add new int neighbor, oh sorry, new int neighbor, uh, comma the frequency. Let's We are just giving it to, and if we don't find the answer, which is I don't think so will be the case that mentioned here, there are no duplicate edges. So yeah, there has to be some answer. It's not mentioned, but let's just say we'll return -1. Okay, now let's give it a run. Oh yeah, and it's accepted. Now let's submit it. Okay, it's taking a little bit more time. Yeah, and it gets accepted. Okay, and this works really fine as well. Okay, so this was it for today. Thank you for watching.